Hi everyone, welcome to this week's asynchronous course content. This week we are going to be talking about my absolute favorite subject to teach, which is science. And specifically, we're going to be learning about inquiry-based science for students with complex support needs. And again, I'm telling you, science is so much fun and students love it so much that I would and I have taught science all day. There was a point where I was working in, across grade levels, and that's what I did. I taught science all day and absolutely loved it. You are going to have a science lesson that you need to write and that you need to teach in your practicum setting. So let me know if you would like a workshop time outside of class. I am going to give you some time in class to work on your science lesson, but if you would also like some time outside of class workshop time, depending on where your cohort is, I'm happy to do it virtually via Zoom, either with one person, several people, or the whole class. Or if you were on the Logan campus, I'm happy also to do a in-person workshop time. So let's look at what you have due this coming week. And it's not this coming week, it's actually for the cohort I'm working with right now. It's after spring break. But as always, these dates don't apply to every cohort. So you are responsible for looking at the syllabus for your cohort to make sure you have the right date. But you have your discussion guide as always due. You're going to have your math lesson. This is going to be your small group math lesson, which needs to be 2 to 4 students. You have coming up quizzes. You'll have your math quiz, and then down the road, you'll have your science quiz just to let you know ahead of time so you can plan things out, especially if you have spring break coming up next week. You might want to use some of that time to prepare for these things or not. You may just want to relax the whole time, which I encourage you to do that too. And if you have been approved to implement your math lesson in a one-on-one instructional arrangement, then you will be doing your try and apply, which is go on out and try and apply that lesson in the classroom, and then writing up your reflection and submitting that, okay? So we're going to be talking about inquiry-based science. And why is it called inquiry-based science? Well, really, it's all about wonder. I have always looked at science as just the world of wonder because what you're really doing is teaching students to inquire or to ask questions about the world around them. And then you're going to teach them, like, how do I find out the answers to those questions? And you're going to be doing that through like things like experiments. Students love experiments, investigations. And so it really is an inquiry-based process that is very different than how you teach reading and math or even writing. Because inquiry-based science is primarily student-led. Now, they're not deciding the content that they're going to learn, but they're leading the lessons. They're leading the experiments. They're leading the data collection and analysis, obviously with your guidance and support as needed. So really, we're teaching kids to wonder about the world around them and then to ask questions about the world. And we're going to teach you how to find out the answers to your questions. So it's going to be an introduction to inquiry-based science, and this is the only week we have to have for science. So make sure you stay really like plugged in throughout our videos and our content presentation this week. There are some steps you go through to build a science lesson. You're going to learn about things called concept statements and wonder stories. And then I'm going to share with you, super exciting, a brand new science framework that just came out in February by Dynamic Learning Maps, which has been adopted through our state on how do you plan a science lesson. And you're going to use that when you plan your science lesson for your practicum setting. If you want to see your objectives, as always, they are in the PowerPoint as well as on Canvas. All right, so let's get started. And I'm keeping track of our questions because one of the students asked me to, so they would know how many questions there were. And your first question is, with all we have to teach our students with complex support needs, reading and writing and math and functional skills, we need to make sure they have their daily living skills, they have their vocational skills, their leisure and recreation skills. Why are we spending time teaching science to students with complex support needs? So go ahead and stop your video for a quick write, and that is question number 1. Why teach science to students with complex support needs? Stop your video, and I'll see you when you come back. All right, let's look at some of the reasons why you would teach science to students with complex support needs. Well, so students can learn about the natural world, the world in which they live. Think how cool it was the first time you learn about the planets. That's your world. That's part of your world, and it's wondrous. That's the natural world. Think about the first time you ever, and we'll be looking at a lesson on sink and float, but if you've ever worked with little kids like preschoolers, kindergarten, and you do sink and float, oh my gosh, how much fun is that to learn about what sinks and what floats? I mean, those are just some like hurricanes, super interesting stuff in my world. But not only that, we want to promote the process of inquiry. We want to teach students to ask questions. I cannot stress enough that we have to teach asking questions. That is not something that comes naturally for a lot of our students. I just did a big study on opportunities to respond, and the number of students that asked questions was so small, tiny. So we want to teach students to ask questions and to be curious and explore their world. And not only that, we really want to build that sense of wonder. Because if you've ever thought, and I know you have, you all are learners, about something that you were like, oh my gosh, I wonder about this. I wonder how a computer works. I wonder what happens if I were put a plant in a closet and it didn't get light. And so we want to teach our students to build that sense of wonder with them. And so back in 2013, the National Research Council came out with what are known as the Next Generation Science Standards. And they really created this because they wanted science. Science needed to change. There had been all of this new research about science and learning. And so they wanted to update the standards to address that. They also wanted to integrate science practices with science content. Because when I was in school, we learned a bunch of science facts, we learned a bunch of science vocabulary, but it wasn't really until I got into like high school, like biology or chemistry, that we did an experiment. We didn't do a whole lot of them, or that we did really deep investigations. It was more about learning facts. Well, now there are things called science and engineering practices. Things like building a model. Think how cool building a model is. And that's a science and engineering practices. So we wanted to include not only those practices, but also engineering. And you'll learn about that as we go through this week's lessons. And then we really wanted to improve what's called the national coherence across states, because states were just all teaching different things in science at different grade levels. And as always, we wanted to prepare our students who were interested in going forth for colleges and career readiness. It was important for that. So I also let me click on this real quick so that you can see. So if we come over here, I'm just going to click on any grade. You can see what the next generation science standards look like. So I'm just going to pull those up. And here they are. So here's one on motion and stability. So if I pull up the standard, you can see it gives me the standard. Here are the science and engineering practices related to those standards. And you don't understand that yet, but you're going to, because we're going to be learning about it. The disciplinary core ideas, and then the cross-cutting concepts. And so again, here's some more information about how you could build in ELA and literacy, and how you could build in math. Because when you're teaching science, you want to make sure that you're integrating ELA and math. Such a great place. You're going to have to read about things as you are doing science. Science is ripe place to embed math. And so we'll be talking about that a little bit more. So just kind of want to let you know that's where it is. We are going to be, I just wanted to do this so when I go back, I can actually see the PowerPoint. We're not going to be working with the next generation science standards. We're going to be working with the DLM essential elements in science, but I do want to let you know that they are based on the next generation science standards. So let's talk about a model for science lessons. So when you're teaching science lessons, this is really what it's made up of. This is, if you think about all of these things, this is what you need. You need something called a wonder story. And again, we're going to talk about that in a minute. You're going to need an experiment, or if you can't do an experiment, because if I'm talking about the North Pole, I can't go to the North Pole to do an experiment. but you could do an investigation. So a wonder story, an experiment, or an investigation. You're going to use something called a KWHL chart. And a lot of people have heard of a KWL chart. This has the H because it's science and how are we going to find stuff out. So KWHL, you'll see in a minute, is what do you know? What do you want to know? How are you going to find out? And then what did you learn? And then when you put all of those things together, that is inquiry science. That's teaching students to ask questions, to explore those questions, and to find those answers. And so here is just a partial example, and I'm going to have to add a sentence because this is only one page of the story. There's another one, but this is an example of what a wonder story is, and it's called My Dog Lucy. And what this really does is it sets up the science lesson and ends in what's called a wonder question, and that leads to what you're going to be learning about. So when I was a little kid, my dad brought home a puppy. She was tiny, fuzzy, and loved to cuddle. She had a little nose and a round face and tiny paws. We named her Lucy. As time went on, Lucy got bigger and bigger. She wanted to play fetch all the time. She ate and ate. It seemed like she was always hungry. Pretty soon, Dad said she was full grown. Her nose was long and her paws were huge. And then you would put a wonder question that would be something like, I wonder, as I was looking at Lucy, I wondered to myself, why was she small? She was little when I first got her, and then she's bigger and full grown now. And so that would set me up for a lesson about growth and what an animal needs to live, survive, and to grow, for example. And so here's what a KWHL chart looks like. So you always have a slot for what do we know? What do we want to know? How are we going to find out? And that's going to be through an experiment or an investigation. And then what have we learned? And note that there is always a prediction in a science lesson. And again, we'll talk about that down the road. This is just a preview, an overview of it. So, how do we even build a science lesson? Well, the first thing you do is you focus on the core ideas or the content areas within science. And so, what am I talking about? Well, in science, there are core ideas, and I refer to them in my mind as the big ideas of science. This is what it's really all about. Because when you're in Gen Ed, they go into a lot of detail. But if I was looking at, like, what do I want the student to learn? What's the biggest thing I want them to walk away with? That's what a core idea is. And so the big core ideas, and we refer to these as the disciplinary core ideas or the DCIs. This is important. So stop and listen because this part is important. The disciplinary core ideas. And there are four areas for these. One of them, and if you think about your science, you learned in all these areas, physical science, life science, earth and space science, and then engineering, technology, and then the application of science. So what does all that even mean? What am I talking about? Well, here, this will be a good screenshot if you don't download the PowerPoints. This is a good one. This is what the next generation science standards disciplinary core ideas actually are. So for science, you're looking at things like from molecules to organisms to structures and processes, ecosystems, heredity, and then biological evolution. So all of those things and anything that fall under those are life science. And don't get overwhelmed by what these are because when you look at the standards, the essential elements, you'll say, oh, that's what that means. Or for physical science, you're looking at matter, you're looking at motion and stability, energy, and then waves, for example. So these are the DCIs or the disciplinary core ideas. All right, so now that we've had a disciplinary core ideas, today, for example, we're going to be learning about life science and we're going to be learning about heredity. That's just an example. The next thing you're going to do is you're going to select your target standard within that core content area. And so let's look at the DLM essential element for science, and this is automatically going to pull up to fifth grade because I had it. So if I were teaching right now, I was teaching a fifth grade class, and now the link is on Canvas to the DLM science essential elements. If I was teaching fifth grade and I'm teaching science, and if you look down here, we are in Earth and Space Science. So if you look at the bottom, you can see what that DCI is. And we're specifically in my class, and when you write your science lessons and when you do what is in this video, do it for your lesson. Pretend like you are planning your lesson, okay? Because then you'll already have it started. So I'm going to pick, and you can use whatever DCI you want. I'm picking Earth and Science and Space Science, and this is about the solar system. And so I am looking at that my DLM essential element is to use data from different times of the year to determine seasonal patterns in the number of daylight hours. So looking at seasonal power patterns for the daylight. All right, let me move back to our PowerPoint. And I can never tell. Sometimes it doesn't share and other times it does. So what I'm going to do is I'm going to unshare and then reshare. So what I want you to do now is I want you to stop the video. I want you to go to the DLM Essential Elements for Science, and I want you to pick out an essential element that you are going to teach your students. I encourage you, you can do it as practice, but if you want to save time, pick a real essential element that you're going to use for your lesson, because then you've already started that project. So I want you to look at the disciplinary core ideas, write down what the DCI is, and then find your essential element and write those down. So go ahead and stop your video and do that now. All right, so hopefully you were able to find your essential element that was related to what you'll be teaching in your classroom. All right, so the next thing you're going to do is embed what's called a concept statement in your lesson. And let's talk about what a concept statement is. Well, first, they align with your essential element, which again are based on the next generation science standards, but they have to align, and you'll see why in a minute. Really, what your concept statement is it's something that is going to teach or support the main idea of what you're teaching. So if I'm teaching about the solar system and I'm teaching about seasonal patterns related to daylight and what was it, daylight hours, then I might say something like there are more daylight hours in the summer, for example, and that's going to start to build on that concept. And I would teach multiple lessons to get to address that standard. So well, I just said that. It might take you multiple lessons to teach that main idea. So for example, in this concept statement, this is an earth science one where you're talking about that earth is made of land and water. That's my concept statement. Concept statements always have a blank that students would fill in. And so this is a fill in the blank statement. But the earth is made of land and water. You might teach one lesson where you're teaching the earth is made of land, and that's all you're teaching. You might teach three lessons where you're teaching the earth is made of land because you're teaching about different parts of the world, for example. And then you might teach about the earth is made of water. And again, that could be multiple lessons, depends on you. You're the author of your lessons. So you might teach about the ocean. It's made of the ocean. It's made of lakes. It's made of rivers, for example. And then you're going to make sure that in your concept statement, you're going to have science vocabulary that students don't know. And for them to understand the content and learn the content, you're going to have to teach that vocabulary. And so in this case, for the next concept statement, the concept statement is rocks blank to form new rocks. And the vocabulary is change because that's what happens, right? Rocks change, and when they change, they form new rocks. So I'm going to use constant time delay. Hear that? Constant time delay is what I would use to teach what change was, because that is a key word, a key vocabulary word for science. And so notice that I have that blank there because in your concept statement, when you first present them to the students, you're going to have a blank there. And then at the end of the lesson, you're going to have them go back and fill in that concept statement. And that to me is really what you want them to walk away knowing. At the end of this lesson, I want you to know that the earth is made of land and water. At the end of this lesson, I want you to know that rocks change to form new rocks. And I found this great picture. Look at that. Isn't that great? Because it very clearly shows and supports the idea and the concept statement that rocks form new rocks. All right, we're gonna look at this and then I'm gonna stop this video and we're gonna come back afterwards and I'm gonna give you the opportunity to write some concept statements. So let's look at this. This is from the Attainment Center, the Attainment Company, and this is an example from the early science curriculum. So this is part of their curriculum. And what I want you to notice here is the concept statements. So here they're teaching about rocks and their concept statement is rocks are different. Again, notice the blank because the students are going to fill that in. Now, I want you to notice how over time, over this unit, the concepts are building on one another. So first, rocks are different. Then rocks are made of minerals. And then rocks change to make new rocks. Then soil is made of different things. All land has rocks and soil, and then finally, wind and water change the land. So you can see how all of those build on one another, and look at the vocabulary here. This is the vocabulary that would be related to the concept that you're teaching, and you'll notice that that is what is going in those concept statements. But I want you to see something else. So there's also something called a wonder question, and the wonder question comes at the end of your wonder story, which we'll talk about more in depth in a minute. But because I have this here, I want to show you how they're related. And really, a wonder question, again, is at the end of your wonder story, and it leads the students into your lesson, and it addresses that big idea that you're teaching. And so if we look at the first one, the wonder question is, are rocks different? Well, look at the concept statement. Rocks are different. Did you notice that the concept statement answers the wonder question? So when you think about your wonder question and your concept statement, the concept statement should answer your wonder question. Let's look at a couple of other ones. Is there something inside a rock? And then your concept statement is rocks are made of minerals. Notice how those align with one another. The next one, do rocks change? Is your wonder question, and then your concept statement is rocks change to make new rocks. So again, just wanted you to see how that wonder question and those concept statements align, so that when we go further and we're talking about our wonder questions, and as you're writing concept statements, also for your project, that you have an idea that I need to make sure that my concept statement answers my wonder question. All right, go ahead. I'm going to stop the video now, and I'll see you in the next one.